Question 8. A factory produces a particular brand of cooking oil in two bottle sizes, namely small and regular. The amount of cooking oil in each type of bottle is in millimeters is assumed to be normally distributed with means and standard deviations as shown in the following table. So just before we go any further, I'm just going to define my random variables. I'm going to say let S be the amount or the volume. What do they call it? The amount of oil in a small bottle, and let R be the amount of cooking oil in a regular bottle. So from this I can tell, and from the table I know that S is normally distributed with mean of 545 and variance of 20 milliliters squared, and I'm told that R is normally distributed with a mean of 1020 milliliters and a variance of 50 squared milliliters. Right, so part 1. A regular bottle of cooking oil will be rejected if the amount of cooking oil is less than alpha milliliters. Find the greatest value of alpha to the nearest integer such that at least 97% of regular cooking oil bottles will not be rejected. So that means I want to find the value of alpha such that the probability that R is greater than or equal to alpha is at least greater than or equal to 0.97, that 97% of bottles will meet at least alpha. Well, that's another way of saying that the probability that R is less than or equal to alpha is less than or equal to 0.03. Well, how does this help me? This helps me because I can actually go use my inverse normal function on my graphing calculator. So I'm going to go to my GC now, and I still have that up from question 7. So I'm going to go to my distribution. I'm going to go to inverse normal, and I'm trying to find a 3% area. The mean of my R variable was 1020, and my standard deviation, not my variance, my standard deviation was 50. So if I paste that in, I find that the answer here is 925.9603. So this tells me, when I come back here from GC, that alpha must be less than or equal to 925.9603. So therefore, greatest alpha, or the greatest integer value for alpha, is 925 milliliters. Well, it doesn't even say milliliters necessary, so I shouldn't actually give a unit. Or rather, milliliters I think is put into the question. Right, part 2. Find the probability that the mean of 3 small bottles and 2 regular bottles of cooking oil is less than 730 milliliters. So the mean of 3 small bottles and 2 regular bottles. So I'm going to define a new variable t, and this is going to be the mean, and that's going to be the mean of 3 small bottles, so S1 plus S2 plus S3 plus R1 plus R2. And you can tell that this is going to be normally distributed. What's the mean of this going to be? Well, you add the means for these up, so you get 3 times 545 plus 2 times 1020 from this one, divided by 5 for the mean. And what about the variance? Well, you add the variances together, so you add 20 squared plus 20 squared plus 20 squared, so 3 times 20 squared, plus 50 squared plus 50 squared, so there are 2 50 squareds, and then you multiply the whole thing by 1 over 5 squared, because we're multiplying it by 5. So in other words, the distribution for this variable t is going to be 735 with variance 248. Right. So if you read the question again, it asks what's the probability that the mean of 3 small bottles and 2 regular bottles is less than 730. So we're actually asked what's the probability that T is less than 730. So just remember this is the mean, this is the variance. We go to our GC, we look at our distribution. We know T is normally distributed, so we choose the normal CDF. And the lower bound is infinity because we want to know the probability that it is less than 730. And the mean was 735. And remember, this is the standard distribution, not the variance, so I take the square root of 248. And that gives me the answer, 0.375 to 3SF. So that's 3SF from GC. Part 3. 3 small bottles of cooking oil are randomly chosen. Find the probability that the bottle containing the least content holds more than 547 milliliters of cooking oil. Well, if the one that has the least holds at least 547 milliliters, then all 3 have to have more than 547 milliliters. So what does that mean? So if I want the probability the least holds more than 547 ml, this is equal to the probability that all 3 hold more than 547 ml. So this is just the probability that a small bottle is greater than 547 to the power of 3. So again, we can go to our GC, and if you remember the, what have we got there? Go to our GC, and if you remember the distribution for S, okay, so it's the chance that it is more than 547. So now my lower bound is 547, and for my upper bound I choose a number as big as I can go. The mean was 545, and the variance, or rather the standard deviation, they actually told me this, was 20. So I'm just going to key in 20 here, and I get 0.46. 0.460, and then I don't just want that, I want that number cubed, so I get 0.0974 to 3SF. So this is 0.460 cubed is equal to 0. Why am I doing this? I can just erase that, which I will do. Disappear. This is equal to 0.0974 to 3SF. Okay, last part. Part 4. The factory found out that there was a change in the cooking oil dispensed for the regular bottle. Assuming that the regular bottle of cooking oil has a maximum capacity of 1080 ml, explain if the use of the normal distribution with the given mean and standard deviation is appropriate in modeling the amount of cooking oil dispensed. So, what can we say? So, it's dispensing. Basically, here's the problem, right? It's dispensing some amount, but the bottle can only hold 1080 milliliters, right? So if you think about this, if I've got my normal distribution with the mean at 1080, and there's no problem, sorry, not 1080, at the mean of 1020, there's no problem, having too little. It's always going to fit in the bottle. But what happens if I have too much? In particular, what happens when I reach this limit, 1080? What's the chance that I have too much in this tail region? That means that, it gets truncated. the normal distribution gets chopped off and is no longer symmetrical, is no longer normal, in other words. Well, we can actually work out what's the probability that R, so I want to find out this region in here, I want to find the probability that R is greater than 1080 milliliters, that it exceeds the capacity of the bottle. So I go to my GC, and same as usual, distribution, I want my normal CDF. Now my lower bound is 1080, upper bound is still infinity. Remember, my mean is 1020 and my standard deviation is 50. So when I paste this in, I find that I've got a 0.115 chance of this happening. This is 0.115, which isn't negligible. This is 10%, 11.5% of my data. So there's a there is a probability of 0.115 that the regular bottle cannot hold all of the oil, so therefore normal distribution is not appropriate.